Hi, everybody. I'm Chris Preimesberger, editor of eWEEK. Thank you very much for joining us today for this new segment of eWEEK eSpeaks. It's a series of IT interviews with thought leaders in the business, every sector of the business. And today we're talking to Simon Crosby, who's kind of legendary in a lot of ways. He's been with a few companies over the years and is quite an innovator. Simon is the founder and CEO, is that right, of
No,
Swim IT?
I'm the CTO.
CTO, okay. I love it when one of the founders of a company will not take the CEO job. And there's a lot of good reasons for that, because you are really a technical guy, and it's always a pleasure to speak with you. So Simon, welcome.
Thank you, Chris. Good to speak to you again.
Yeah, tell me a little bit about your background, where you've been before.
So I was the founder and CTO at ZenSource, which was the open source hypervisor, which I guess built EC2. And then we helped Microsoft build Hyper-V, which is
Yeah.
their hypervisor. And then I started a company called Bromium, which used virtualization for security by putting tasks into micro VMs.
Yeah.
And now I'm doing Swim.
Yeah, ZenSource, great company, and Bromium too. So tell me about Swim IT and what problem it solves. I think it's really ahead of the curve. Tell me about it.
Well, our customers are faced with deluges of streaming data, vast amounts. So just as data point, our largest customer, we're dealing with 4 petabytes of data per day. Okay, it's just staggering amounts of data per day. And what they have to do is derive intelligence from that data to make their business function better in various ways. And the problem is that the data itself is ephemeral in terms of value. So you can't stick it on a hard disk and then analyze it later because the data is of no use, right? And so what you want to do is you want to process the data on the fly and analyze, learn, and predict on the fly to derive continuous intelligence, which helps drive your operations. By the way, I think this is going to be the way that all businesses work in future, because every product is instrumented, every IT infrastructure is instrumented, people are instrumented, supplier pipelines are instrumented. So the volume of information is just increasing. And this kind of big data notion of store, then analyze is a little bit long in the tooth.
Okay, give me an example of a use case, Simon, so that our readers can kind of picture what Swim IT does.
I'll give you a couple.
Okay.
For this mobile provider in the US, we continually track and analyze the connectivity between over 100 million endpoints and the network, and continually optimize the connectivity. So which device attaches to which base station and so on. And this produces huge amounts of information. It's situational in the sense that it's it's geophysical, right? So we need to know not only where the thing is, but also what the situation around is, all the mountains, everything else. We need to know where the device is moving to predict where the best place is for it to connect and so on. And we need to continually optimize their connectivity as well as find brown spots and so on in the network. But we're also widely deployed in US cities for traffic prediction. And the information we get from traffic infrastructure is vast. So just for example, Las Vegas is about 60 terabytes per day of streaming data just from the infrastructure. And so what we do is we continuously predict, that is what you can think of as a digital twin for every intersection, continuously predict its future 2 minutes out. And those predictions are streamed to customers like Uber and so on, so that they can better route their vehicles through the city.
Okay, so you're collecting, monitoring, and measuring the data flows from one place to another for intelligence purposes, for efficiency purposes. Is that a fair way to say it?
Yep, it's good enough.
Okay, and so the data itself, you're not really monitoring the data itself for
Oh
intelligence.
yeah, no,
Oh,
we
you are.
understand the data. So what we do is we build a model from the data in memory. So for every sensor attached to an intersection, for every intersection itself, we build a model which is essentially these little concurrent digital twins of intersections, right? And all their sensors and all their neighbors. And so we build an in-memory graph in which these little digital twins link to each other, and linking gives them this ability to use not only their own data, but also the data of their neighbors, say, to continuously analyze and predict their future. And so we actually understand the semantics of the data itself, and we build this in-memory graph, which is fluid based on what we find in the data. And the cool thing about this is that unlike what you normally hear about in machine learning and AI, where somebody has to train a model in the cloud and then push it to the edge or whatever, these are self-training worlds where these digital twins build a model on the fly and then analyze, learn, and predict.
I just put up behind me a graph. This is a visual of a graph database.
Yeah.
And you were just talking about that. Are you working with a graph database? Is that what that is?
No. So in general, the idea that there are cool databases out there, but every time you reach out to a database, you're going 1,000,000 times slower than the CPU. And we can't afford the time, right? So we build there's a graph, but it's in memory. And every vertex in the graph is a concurrent, we call them web agents because in fact they're distributed, these large applications are distributed nationwide. And we need to always be able to find these things. So they each have a URI as the object ID. But the key point is that every vertex is a computational thing which concurrently analyzes, learns, and predicts on the fly as data flows over the graph.
Okay. And you said that, you might have told me earlier before we went on the air, that this really could be the future, or maybe you said it during the show here. Why do you think this could be the future for a lot of other companies?
Well, think about it this way. ARM now ships 20 billion CPUs per year. Okay, it's about 2 million an hour. And all these CPUs have got a lot to say, and they're all connecting to the internet, right? So in general, the idea that big data would work for us forever is kind of long in the tooth. That is the idea that you could store all the data you need. That's a big supposition. And then that you have the capacity to analyze it. So by effectively analyzing data on the fly, we get to reduce it to the insights you want on the fly. And that's massive reductions in the volume.
And okay, so all right, I get that. The data that you monitor and measure doesn't get stored anywhere in the system. It goes right through or not? True or false?
We don't store it. If you really want to store it, fine, we'll make an API call. But the key thing is that we'll analyze, learn, and predict first, and maybe even react, and then store. Because reaching out to any form of storage is 1,000,000 times slower than a CPU. Okay? So we compute driven by data, and then storage runs along behind as quick as it can go.
Okay. All right. If anybody watching the show here would decide that they want to go deeper into Swim, it's swim.it, right?
Well, Swim.ai actually is the commercial side of the operation, but everything is open core. So if you start at swimos.org, you'll find all the code plus a bunch of really cool applications for traffic prediction, for running manufacturing plants, for tracking space junk, for
Wow,
tracking aircraft. These are all open source.
very cool. So they can, so is it a freemium service, or just you can try a few features, or what?
So our customers are organizations that want to work with us because they run applications at scale, and they want manageability, security, availability, and all the LTs that you would think of. And what we're trying to do is encourage people to just get going with this actor model based approach, which is stateful in-memory computation. And so our opportunity is not gated by the fact that the software is open source. Really, it's really gated by just encountering organizations that have the scale we need.
Very good. And I guess my last question is there an open source advocacy group or a team that's helping?
Sure, yeah. You'll find us on Gitter and all the other tools around. So if you have any need for help, then just get hold of us. And I'm Simon at Swim.ai. Happy to take any questions anytime.
Great. Okay. Well, prepare for a deluge then after our readers get a hold of you. So,
thank you, Chris.
Simon, thank you. Simon Crosby, thank you very much for your time today. I always like talking to you. You're way ahead of a lot of us on this, and so you're
always a pleasure, Chris. Thank you.
You're a leader in the area. You're a thought leader. You're a real thought leader. So, thank you for that. And for everybody following along to the end here today, thank you very much for joining us on eSpeaks, and have a great rest of your eWeek. Thanks for joining us on eWEEK eSpeaks. Go to eWEEK.com to hear more conversations with IT thought leaders.